In the last installment, we learned a little bit about why atoms don't have their electrons in orbits around a nucleus, but are rather in orbitals, which are spaces that have where the electrons probably are, not necessarily where they are. Right now, we're going to look at how to make up the electron configuration of an atom, how to figure out where those electrons go in the orbitals. And this skill is going to be particularly important when we go on to learn about the periodic trends and bonding of atoms. So here we have this diagram in white here. It's got the nucleus at the bottom, and then as you get further away from the nucleus and you get higher up in energy, the different orbitals are laid out. The rules for filling up the orbitals is you always start filling your orbitals at the bottom, putting in one electron at a time. Electrons can pair up with one being spin up and one being spin down before you move up to the next level. But if there's an orbital that has the same amount of energy, you will always fill the one next to it before moving up. So let's look at a couple examples. First, let's look at lithium. Lithium has 3 electrons. Let's see how these electrons are placed in the energy level diagram. So kind of by convention, we start with a spin up, designated by an up arrow, electron. That's the first. The second will be a spin down. So there are the 2 electrons there. Then the third goes like this. And so the electron configuration of lithium is written like this in shorthand without the diagram. Is 1s2 for 2 electrons in the first energy level, 1s, and then 2s1 for 1 electron in that second s sublevel. If you add up the superscripts, 2 plus 1 is 3. That's the 3 electrons lithium has. Let's go on to nitrogen. Nitrogen has 7 electrons. So let's start with the 3 that we already have in place from lithium, and let's add 4 more. So the 4th electron is going to go into the 2s orbital and is going to be spin down. The 5th one is going to go into, just having problems grabbing these arrows, it's going to go into the 2p and be spin up. Now, because there are 3 2p's, we do not pair up with this electron yet. Okay, so the 6th now electron goes into the next 2p, and then the 7th goes into the final 2p orbital. So nitrogen has 3 unpaired electrons in the 2p orbital. Its electron configuration would be written like this: 1s2, 2s2, 2p3, and you can see when you add up this, again, the superscripts, 3 plus 2 plus 2 is 7. You can also make the energy level diagrams for ions. If you look at the O2 minus ion, now oxygen is right next to nitrogen on the periodic table, so normal oxygen would just have 1 more electron than nitrogen does. Whoops, don't want that one. Let's get rid of that because I want to spin down. So normal oxygen would have just 1 more. Would have just 1 more, but since this is O2 minus, it has 2 additional electrons, because remember the way you become an ion is for every negative charge you have to have an extra electron. So we have to have 2 additional electrons, 1, 2, making a total of 10 electrons for O2 minus. As we'll see later on, this is the same electron configuration as the noble gas neon, which is why oxygen really likes making these 2 minus ions. So the electron configuration for oxygen is 1s2, 2s2, 2p6. Finally, let's go on to iron. Iron has 26 electrons, and so we've already got 10 placed in here, so let's keep going. So there's 10. Oh, wait, go away. Here's 11, 12, Should have made these arrows a little shorter. 13. And I'm putting them in the order that we would fill them up. 14. 15. 16. 17. 18. At this point, you're all thinking, wow, Mr. Kehoe can count. So now we're going on to the 19th. The 19th one starts the 4th energy level in 4s1. The 20th goes into 4s2. Now, you would think you would go to 4p. The 3d is actually in between the 4s and the 4p. You would think the 3d would be under the 4s, but just for reasons, you know, in calculations and the way nature works out, it actually is underneath. So we run 20. Here's 21. 22, 23, 24, 25, and then finally the last one goes in spin down, 26. So iron has the electron configuration of 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. Now, that's, filling in arrows usually isn't too difficult for people once they have the diagram and they know the order that things go in. However, it's not always necessarily the fastest way to fill. So what we're going to turn to now is the periodic table. We can also read electron configuration straight off the periodic table. The way we do this is by looking at the periodic table, and excuse me a minute, I should have already made this. The periodic table can be broken into different blocks by the way it's arranged. So we have the S block here. So all of these elements, their electron configurations end with S. Then we have, let me just change the color of the marking here. We have the P block. All of these elements have electron configurations that end with P. Get a different color. Then we have the D block, which is the ones in the middle here. Sorry if that green's a little hard to see. And then finally, the very bottom is called the F block. So we'll type those in for you. So again, this one, oh, that's going to be a really big font. Let's make that smaller. So off on the side is the S block, and you might want to just diagram or have a diagram somewhere. Get your periodic table in your planner and just write these in so you have them to remember. This is the P block. This middle one is called the D block. And then down here is the F block. When you're reading off the electron configurations of something, all you need to do is look at what you have to do to get there. So hydrogen is the first atom into the S block in the first row. Its electron configuration is 1s1. Let's go for something harder. Let's go to nitrogen, which we did in the example last time. Let's see how I can read off nitrogen's electron configuration. What I do is I read off everything I have to do to get to nitrogen. So I start off with hydrogen. I say 1s2, because I have to go 2 into the S block. For here, you could imagine helium's over there. So again, 1s2, second row, 2s2, still in the second row, 2p1, 2, 3. So to get to nitrogen, I had to go 1s2, 2s2, 2p1, 2, 3. So that's nitrogen's electron configuration. let's go to iron. So rather than having to put in those 26 electrons, so actually I'm just going to clear off what I've already done. Okay, so going to iron now. Again, I start at hydrogen. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. And now the confusing part comes is you'd want to say that since this is the fourth row of the periodic table that these would be the 4Ds, but they're actually the 3Ds. So 3D1, 2, 3, 4, 5, 6. So iron is 3D6. Let's look at one more. Let's see here. Get the spray bottle, clean your stuff off. All right, let's do arsenic. So again, to get to arsenic, I go 1s2, 2s2, 2p1, 2, 3, 4, 5, 6. I won't count them all next time. 3s2, 3p6, 4s2, 3d, all 10 of them, and then 4p1, 2, 3. So again, arsenic would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p3, and a partridge in a pear tree. All right, so hopefully this will kind of give you an idea of what it looks like to find these electron configurations. And again, we'll be working more with it in class.